Welcome to this explainer. Today, we're breaking down the architecture you need to build fast, reliable, and seriously scalable data processing systems. Look, if you work with data, you already know the stakes here. Keeping enterprise systems organized and responsive isn't just a minor challenge, it's a massive technical hurdle. So, we're going to unpack the exact blueprint you need to completely streamline those workflows, transforming some pretty complex architectural concepts into clear, actionable insights that you can take straight to your engineering teams.
Here's our roadmap for today. First, message-oriented architectures. Second, pipelines with data flow. And third, the reference architecture. Let's get right to it.
Okay, before we dive into the specific tech, we really need to establish the real-world challenge at the very heart of modern data engineering. Today's systems basically demand that we tame two completely different beasts. On one side, we have data that's happening right now, that's real-time processing. On the other side, we have data that's processed in large, scheduled chunks, which we call batch processing. Figuring out how to handle both of these seamlessly, without pulling your hair out, is the overarching goal of the architecture we're analyzing today. So let's look at the core differences between these two paradigms. Real-time data processing is all about capturing and analyzing data the literal millisecond it's generated. Think about a credit card swipe. You have to analyze that transaction for fraud instantly, right? You absolutely can't wait until tomorrow morning to figure out a stolen card was used. Real-time is unbounded. That stream just never stops. Batch data processing, on the other hand, deals with massive volumes of historical data all at once, usually on a set schedule. Imagine processing petabytes, literally petabytes of nightly sales logs from thousands of retail stores just to generate a single daily revenue report. That's a bounded data set. It has a clear beginning and a clear end. The architecture we're exploring today has to efficiently juggle both of these completely distinct worlds, the unpredictable instant streams and the incredibly heavy scheduled batch loads. Section 1. Message-oriented architectures. When you're building these complex systems, whether it's for real-time streams or massive batch jobs, the immediate architectural dilemma you hit is this: how do we actually handle the messages? Imagine data flying into your system at a rate of 1 million events per second. Maybe it's a huge spike in user traffic or a flood of IoT telemetry data. If your downstream database tries to swallow all of that instantly, it's going to choke and crash. In modern distributed systems, data doesn't just sit in a silo, it moves. It moves as events, or messages, from one microservice to another. Figuring out how to ingest, buffer, and distribute those messages without completely overwhelming your downstream systems is step 1. You desperately need a way to absorb the shock of those unpredictable data spikes. And that exact challenge is solved beautifully with pub/sub, short for publish/subscribe. PubSub acts as the foundational shock absorber for your entire architecture. Here's how it actually works under the hood. It completely decouples your data producers from your data consumers. Instead of a producer application throwing data directly at a consumer and just crossing its fingers that the consumer can handle it, the producer simply pushes events to a central topic in PubSub. Bam, the producer's job is done. Then, the consumer applications independently subscribe to that topic and pull the messages at their own pace. If there's a sudden massive spike in traffic, the consumer doesn't get flooded. PubSub securely holds every single piece of data until the consumer has the compute capacity to actually process it. It provides strict delivery guarantees, meaning zero lost data even if a piece of your system temporarily drops offline. It is the ultimate buffer. Section 2. Pipelines with data flow. All right, so you've got your message-oriented architecture down. Your data is securely buffered. Think of PubSub as this massive, highly reliable receiving dock. It catches every single box coming off the trucks. But once the data is sitting on that dock, it needs to be unpacked, sorted, transformed, and delivered. That is exactly what a pipeline does, and creating these pipelines using Dataflow is the next crucial piece of the puzzle. Dataflow takes those raw messages and turns them into highly structured, valuable info. Mechanically, it allows you to perform really complex transformations at scale. Say you're reading an unbounded stream from PubSub. Dataflow handles windowing, which is basically grouping real-time data into logical time chunks, like aggregating website clicks every 5 minutes. It filters out corrupted data, it executes complex joins on the fly, and the absolute best part? It scales automatically. If your pipeline suddenly needs to chew through terabytes instead of gigabytes, Dataflow just dynamically spins up worker nodes behind the scenes to handle the load, and then spins them right back down when things quiet down. You catch the data with PubSub, and you process it with Dataflow.
Section 3. The reference architecture.
Ultimately, all of these technologies get synthesized into one cohesive blueprint.
A specific reference architecture for real-time and batch data processing. Because let's be real, you don't want to just deploy PubSub and Dataflow randomly. In an enterprise setting, relying on a reference architecture is absolutely critical. It's your gold standard template. Why does this matter? Because it guarantees consistency and security across all your engineering teams. When a new team needs to build a pipeline, they don't have to start from scratch, patch things together, or guess the best configuration. They just follow the blueprint. It shows exactly how to snap these managed services together to create a robust, production-ready system right from day one.
And this brings us to the ultimate takeaway of this entire explainer: streamlining real-time and batch processing into one unified reference architecture. Historically, data engineering was honestly a bit of a nightmare of duplication. Companies had to build one totally separate tech stack for real-time streaming, and then another completely separate stack just for historical batch data. You're talking 2 code bases, 2 deployment pipelines, double the engineering overhead. It was a mess. This unified architecture fundamentally fixes that. It gives you a unified programming model where you write your code exactly once, just once. You write a single processing pipeline, and you can execute that exact same code across both your batch datasets and your real-time streams. By pairing PubSub's decoupling with Dataflow's unified model, you handle both processing paradigms seamlessly within a single, highly streamlined system. So, you now have the blueprint to handle massive batch loads and instant data streams together. Think about the bottlenecks you're currently dealing with in your own pipelines. Consider just how much technical debt and daily operational headache you could eliminate by writing your transformation code once and letting fully managed services handle all the buffering and autoscaling. The only real question left to ask is, what incredible system are you going to build with it?